Now that we know how to use the formula to find the derivative, which is the slope of the tangent line, we can find the full equation of the tangent line. We already know that the derivative of the function at x is going to equal our slope. And we also know the formula for a point slope is y equals m times x minus x1 plus y1. So if we put that together, we should be able to find the equation of the tangent line of a function like 3x squared minus 4x at any point. Let's say the point 2, 4. The first thing we're going to do here is find the slope of the tangent line, which is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Which means if we've got f, we still need to figure out what f of x plus h is going to be. And that's going to replace each of the x's with x plus h, giving us 3 times x plus h squared minus 4 times x plus h. And if I square that out, we'll get 3 times x squared plus 2xh plus h squared. Again, remember when we're squaring a binomial, we multiply those together and double it. Minus 4 times x plus h. Distributing through, then, we get 3x squared plus 6xh plus 3h squared minus 4x minus 4h. Now that we've got that x plus h, let's plug it into our formula. So we have the slope is equal to the limit as h goes to 0 of f of x plus h, which we just found out is 3x squared plus 6xh plus 3h squared minus 4x minus 4h, minus, always in parentheses, the whole function, 3x squared minus 4x all over h. The reason that this parentheses is important is that negative is going to distribute onto both parts, making it now a negative 3x and a positive 4x. Then simplifying, I see we've got a 3x squared and a negative 3x squared. I see we have a negative 4x and a positive 4x, which means all that's left is the limit as h goes to 0 of 6xh plus 3h squared minus 4h all over the h. Again, we want to reduce out that discontinuity, remove the discontinuity by factoring out the h. So we have the limit as h goes to 0 of h times 6x plus 3h minus 4 all over h. And when I reduce out the h, we've removed the discontinuity, so I can plug the 0 in for the h. And so we have 6x plus 3 times 0 minus 4. But 3 times 0 is just 0, which just leaves us with 6x minus 4 is the formula for the derivative. What we're particularly interested, though, is this point at 2, 4. 2 is the x, 4 is the y. So I'm going to plug into the x value, to find the slope at that point is 6 times 2 minus 4, or 12 minus 4, which is 8. Then we can go to our slope-intercept equation to get the equation of the tangent line at 2, 4 through our function. The tangent line is y equals m, my slope, we just found out is 8, times x minus the x-coordinate of the point is 2, plus the y-coordinate, which is 4. And we have the equation of our tangent line at that point. It's your turn to practice some of these, finding the derivative using the definition. Make sure you're showing all your work on every step, and then also finding the equation of the tangent line.